So as promised, I'm going to make a quick video over questions 24 and 25. I didn't get any requests for any other questions from you guys, but if you do have any later, please, please, please do not hesitate to ask me. Thank you to Jade for taking a picture of question 24 and 25 and sending it to me. Your all's idiot teacher left his copy of the review at school. I'm a moron. So that reminds me too that if you do have questions that you want me to review in subsequent videos after this one, please take a picture of it as well and send it to me. Sorry to make you guys put in that extra effort, but I do want to make sure that I address any questions you have, and don't feel like you all are bothering me either. Really, I'm open to doing math all night long. I promise. So if you send me questions, I will answer them unless I'm asleep. Tonight I should be awake for a while because I went to bed kind of early last night, and I've got a lot of work to do for UK this evening, so I'll probably be up for a while. Anyway, for question 24, you're given an endpoint, a midpoint, and it's asking you to find the other endpoint. So we can really just go back to the midpoint formula, and remember the midpoint formula is the sum of the x values and the sum of the y values, both divided by 2, and that'll give you the midpoint. Well, in our case, we're given, we know the endpoint, and we need to come up with the other endpoint that generates the given midpoint. So let's look at the x values. We know the midpoint is -10, and that's going to be equal to our known x value plus our unknown x value divided by 2. So multiply both sides by 2, and then we'll add 7 to both sides, and that's going to give us a x value of -13. We repeat the process for the y values, so we have a known midpoint y value of 6, and we have a known endpoint y value of 5, plus our unknown endpoint y value divided by 2. Multiply both sides by 2. Subtract the 5. And we're going to generate the other endpoint as -13, 7. So there is the other endpoint. When you couple that with the endpoint -7.5, you will generate the midpoint -10.6. For question 25, this is one I know that when we covered it initially in class that some of you did get a little bit tripped up on, and it's nothing too difficult. Just you want to make sure that you use the distance formula when you solve this. So you're given a known x coordinate, and you want to find all the points that have that x coordinate that are 10 units from the point 3, 2. So let me just write this down real quick. So here's what we know. We know the distance is 10 units. We know that we have an x coordinate of 9 minus our x coordinate of the point that we're evaluating, which is 3, quantity squared, plus we do not know our y coordinate corresponds to 9, so that's what we're solving for. And then we have our other known y coordinate, which is -2. So instead of writing y minus -2, I'm going to go ahead and write this as y plus 2. And now let's start simplifying things a little bit. So underneath the radical, we have 9 minus 3. And I won't skip steps, so we'll just put down the 6 squared plus y plus 2 quantity squared. And that's going to give us 36 plus y squared plus 4y plus 4. That's the expansion of the y squared, or y plus 2 quantity squared I'll take a little detour right here and expand that out for you if you don't see how I came up with that. That implies y plus 2 times y plus 2. So y times y times 2, 2 times y, and then 2 times 2. And then when we simplify that, we get y squared plus 4y plus 4. So that's this term, or these three terms right here. So now we can combine like terms. So now we have 10 is equal to the square root of y squared plus 4y plus 40. And I know somebody in class was working on this one, and I think they made it to this part and they were kind of stumped on where to go from here. So since we're solving for y, if we square both sides, what we end up with now is 100 is equal to y squared plus 4y plus 40. And we see that we have a quadratic on the right and we have this constant on the left. Well, we can solve quadratics, but only when they are equal to 0. So let's subtract the 100 from both sides. And you get y squared plus 4y minus 60. So now we want to look at this and determine, is there a way to factor this trinomial to come up with the zeros that would give us the two y values that correspond to the x-coordinate of 9 for the points that we're looking for. So we could look at factoring, or you can, let's see, y squared plus 4y minus 60. We can go to the calculator and find the zeros, and I'll show you how to do that. I'm going to type in x, so don't get thrown off by this. So we're going to do x squared plus 4y minus 60. When I graph that, okay, I don't see it here on the graph, so I need to zoom out. But when I start to zoom out, I put y. There we go. X squared plus 4x. Wow. There we go. X squared plus 4x minus 60. Now I have the graph. Let me zoom back in. Zoom standard. So I still need to zoom out just a little bit, but this is going to make more sense. So the two locations that you see here, to the left of the y-axis and to the right of the y-axis, those are the solutions to that quadratic x squared plus 4x minus 60, or in our case y squared plus 4y minus 60. So we want to find those values. So we go to menu, analyze graph. We can find the 0, and you can see in the bottom left corner of your calculator it's going to ask for a lower bound. So move to the left of the 0 and then to the right of the 0, and then do that again for the opposite side. So menu, analyze, 0, and you get negative 10, 0, and 6, 0. If we'd done this by factoring, we would have come up with the same values, because the factors of negative 60 that add up to our middle term of positive 4 are negative 10 times 6, and when I add those together I do get a positive 4. So I know factoring is something that we do need to work on in here as we progress through the course. But anyway, what that tells us now is that we have 0 is equal to y minus 10 and y plus 6. So the 0 product property tells us that if we take either one of the factors and set them equal to 0 and solve for our variable, we get y is equal to 10, y is equal to negative 6. So we know our x-coordinate, our given x-coordinate at the very beginning of this problem was 9. So we have the ordered pairs 9, 10, and 9, negative 6. So those are the two other points that have x-coordinate of 9 that are 10 units away from the given point. I believe it was 3, negative 2. Yeah. Sorry about the calculator confusion there a minute ago, but that's how you work out that problem. So again, if you all have any other questions between now and tomorrow morning, please ask me. I will do everything I can to make sure you are successful. You all have a great night, and hopefully I'll hear from some of you soon.